Hi, morning, afternoon, evening, from wherever you're joining. I will just leave 20 seconds to give a chance to other people to join. Okay. Hi, everyone, and welcome to this webinar. Well, the title doesn't really leave room for suspense. If you're here today, it's because you're looking for options for your virtual machines. Whether you have been stung by Broadcom doubling or tripling or even more your VMware renewals, if you experience challenges with the Broadcom partner programs, if you're unsure that vSphere will continue to remain a reliable and sustainable solution, you have probably been looking around at your options. My name is Romain Decker, and I'm working as a product manager at Spectro. I had various roles in my career, including being a virtualization admin and architect. I designed all kinds of VMware environment with vSphere, NSX, VMware Cloud Director, and other products for small to large scale organizations. I also spent almost 9 years at VMware working in different roles. And I'm also a VMware Certified Design Expert, VCDX number 120, the highest certification that exists for VMware products. We are just above 300 people in the world with that certification. In terms of agenda, I will cover 3 main topics today. You're looking for new places to home your virtual machines, and I will just recap the challenges that you may experience. I will also describe your options, the potential path that you can test or adopt. And finally, I will present our solution virtual machine orchestrator, or VMO, and I will finish with a technical live demo, so ensure to stay to the end. In terms of housekeeping, let's keep this interactive. If you have any question, please drop them in the question section. I think there is a question mark icon in the interface. We are also recording this webinar, and the recording will be available on demand. You're here today because you're like those 85% of Kubernetes decision makers that are already looking at what to do with their VM workloads. I'm not here today to persuade you to move out of VMware. I guess some of you already are convinced or made the decision. Those are some key findings from the 2023 State of Production Kubernetes report, which is a survey that we conduct with an independent research house. So they ran an in-depth survey with more than 300 well-qualified professionals, whether practitioners or decision makers. They only have in common that they are running Kubernetes in production. So what haven't happened in the past 2 years in the IT landscape that is impacting tens of thousands of organizations around the world? And by event, I don't mean IT conferences. The VMware acquisition by Broadcom, of course, announced a month ago in May 2022 and finalized a few months ago. I was still working there when all VMware employees, we got an internal email from Raghu, our CEO, explaining that we got an unsolicited offer from Broadcom. No one can really imagine the impact that VMware had on tens of thousands of small to large scale organizations. They revolutionized the IT industry for the past 25 years, transforming how organizations deploy, manage, and scale their computing environments. So what aspects of this acquisition are actually affecting the IT industry? Well, there are many of them. Impact on price and licensing. So VMware stopped the perpetual licensing. Everything is subscription-based now. The impact on the go-to-market. The interaction with partners. So they just ended all the partners agreement back in December, and they rearranged all the partner organization. The whole set of products and suites of products that completely disappeared from VMware portfolio, and the list goes on. So there's a sense of urgency for these VM issues. 63% of our survey respondents said that their costs for running virtualized infrastructure, such as VMware annual licenses, are no longer sustainable for them. And for more than 2 decades, organizations have relied on virtualization technology to deliver innovative applications and services. The introduction of virtual machines into data centers helped the IT teams to efficiently use resources, improve flexibility, and optimize performance. And it's not finished. Actually, last year, Gartner published its market guide for server virtualization. And I quote that despite cloud migration and container adoption, 70% of data center x86 workloads, 70% of those workloads will continue to use hypervisor-based virtualization through 2027. But why is that? Aren't we in 2024? Is not all applications have migrated to cloud or cloud native? Well, in IT, greenfield has always been easy. But what do we do with existing workloads? We have seen massive adoption of containers and cloud native technologies. But the reality is that virtual machines are here to stay. For most organizations, even if they have a mandate to move to cloud native, refactoring all the applications represents a significant amount of work. And even VMware, they claimed a few years back over 85 million VMs running on top of vSphere. And that number is only growing. So what are the options for your VMs? Well, they are probably not a good fit for public cloud, or they would have been migrated by now. AWS EC2 is almost 20 years old now. And from a personal perspective, I've been there, done that. I had a lot of interactions in the past 10 years with past customers, that wanted to move to the cloud, either because they had real requirements to do that, or constraints, compliance, or acquisition, merging, or just because it was trend. Okay, so what's the next option? Yet another hypervisor. Why not just continuing the same operating model and just replace the hypervisor to a new one? VMware products were and are still very good, but they are not the only options. Organizations always had the choice. And well, if you see those logos, some of them looks very familiar, no? So several of those technologies use KVM. So KVM stands for kernel-based virtual machine, which is part of Linux. Any Linux kernel above 2.6.20-ish something, any kernel Linux released after 2007 on x86 with hardware virtualization technology supports KVM. But KVM by itself doesn't provide out of the box the same level of features or functionalities as vSphere. And that's the reason why it's wrapped inside one of those products. But moving to another hypervisor, whether it's KVM, Oracle, Microsoft, to be fair, you're just swapping one set of proprietary technology for another, which may be similar in terms of license cost, plus all the pain of migration and reskilling the IT teams. So it's one big vendor proprietary lock-in approach. And well, if you want to move out of vSphere because of the current challenges, why jumping straight ahead to one other mega vendor that may have the same business principle or the same long-term challenges? Some people don't like the analogy, but this feels like I'm swapping one physical network switch from one vendor to another physical network switch from another vendor, like a Cisco switch to a Dell switch, an Arista switch to a Juniper switch. Of course, you will always have people that says that like we are not exactly aligned in terms of features parity, but at the high level, that's the same product, it's the same concept. So moving to cloud, swapping hypervisors, but why not taking the process or the thought process a bit further? Instead of merely swapping the hypervisor, why not considering a cloud native approach and choose a virtualization platform that can future-proof your investments? And this can be achieved with the third option, which is to run and manage your virtual machines in Kubernetes. That's a true opportunity to maintain existing VM investments, but also to create a new path for containerization at the same time. With that solution, you don't need to be in a hurry to replatform your applications into containers. It allows you to modernize your applications over time on your schedule. I'm sure that by now you all have cloud-native applications, either in test, but most certainly in production. So this third option to run VMs on Kubernetes allows you to accelerate to where you were already going. You're already adopting Kubernetes and cloud-native stacks because it gives you the choice, the agility from cloud to data center to the far edge. And you can bring your VM workloads directly into Kubernetes. You can run your VM alongside your containerized workloads and benefit from one unified management. So you don't have any more two IT estates. It's only one. And because of that, you can reduce your dependency on VMware or other hypervisors. Okay, so we have seen options. So moving to cloud, switching to just swapping the hypervisor, it's just a temporary solution for me. Running VMs on Kubernetes? Okay, well, the common underlying technology that fuels that option is KubeVirt. So it's a virtual machine management add-on for Kubernetes, which enables it to provision, manage, and control VMs in the same infrastructure as containers. So it was initially created by Red Hat in 2017, but it's now a cloud-native computing foundation, CNCF, incubating project since 2019. And because virtual machine runs as pods in Kubernetes, they also benefit from the same benefits that Kubernetes has. The same declarative model as Kubernetes, the same choice in storage and network plugins, the built-in features for high availability, scheduling, desired state, intended state, and so on. The integration with the Kubernetes ecosystem for role-based access control, for monitoring, logging, service mesh technologies, and so on. Let me just grab it to see if there are any questions. There is one question that will be addressed in a couple of minutes, so I will just answer it directly later. Okay, so we went from the path on why we decided to run VMs on Kubernetes to the options and so on. So you have decided now to run VMs on Kubernetes. So now that we are with KubeVirt, just with KubeVirt, what are the options? So the first option is to use a solution from another vendor. You have Red Hat OpenShift virtualization, Rancher Harvester, but Red Hat is another mega vendor that is known to require heavy professional services to implement their solution. I worked with them in the past, and you just VMware to jump into another similar vendor. Rancher Harvester, it's open source. It's great to test and to use into small silo, but really it's very opinionated. It's a very specific stack, a bill of material with very specific storage, versions of Kubernetes and so on. And it only provides a hyper-converged solution. It doesn't allow you to have like centralized storage and so on. Another solution is to completely do it yourself. KubeVirt is completely open source. You can just right now jump into GitHub and check the documentation to install it by yourself. But it's very manual. So you may face challenges by integrating and ensuring the compatibility of all the required components. For example, to start, you need a running Kubernetes cluster on which you install the KubeVirt operator. You need to deploy the KubeVirt custom resource definitions, the CRDs. You need to deploy the KubeVirt components. And you need to do that for every cluster where you want to run VMs on. So one more thing, it's basic installation. That basic installation allows you to just run VMs. But if you want some advanced features such as live migration, cloning, snapshots, you need additional components that are not installed yet. And when it comes to day-to operations, KubeVirt itself, it leaves the users with manual heavy lifting. So if you're running at scale, performing such operations daily across many clusters at scale, the effort can be considerable. Of course, you can always build scripts and CI/CD pipelines and so on, but just increase the learning curve and it adds to the setup cost. But what if I told you that there's a solution that can combine the best of both worlds? The maturity of an enterprise platform associated with the flexibility and the openness of the cloud native landscape. And this is Virtual Machine Orchestrator, aka VMO. And this is offered with Spectro Cloud Palette. So VMO, it's a pre-configured and curated version of KubeVirt, certified and tested by Spectro Cloud. It's completely pre-configured and it's supported end-to-end so that your IT teams don't have to install and configure all those independent components across all the clusters. But how are we different from other vendors? Well, we have a unique approach to full stack bare metal, Kubernetes, where the operating system, the OS, is just another layer that you don't have to manage separately, as opposed to all those bring your own OS approaches. Also, through our canonical MAS or other providers, CAPI provider, it means more resiliency. So if a node crashes due to hardware failure, Palette will detect and replace that specific hardware node through cluster API via MAS that will launch a new node automatically, as opposed to other solutions that are treating completely the hardware in a static way. VMO also aligns with our concepts of cluster profiles and desired state, which brings repeatability for faster and more resilient deployments. And finally, the choice of integrations. It provides flexibility in choice as we're using vanilla Kubernetes, but you have completely the choice of the Kubernetes distribution and version. We support more than 50 plus out-of-the-box integrations for both containers and VMs. Well, and that all of that offer choice and no vendor locking. So Palette Virtual Machine Orchestrator, or VMO, allows teams to manage both VMs and containers in a data center or at the edge in order to support hybrid applications, or to slowly move from VMs to modernize your applications, so to refactor your applications at your pace, or just to maintain standalone applications that need to remain hosted in VMs. VMs are treated just like containers, which means that with our powerful declarative orchestration, the state is always maintained as intended. So VMO, it's a feature that builds on top of Palette, and it adds the ability to deploy and manage virtual machines on top of all the clusters that are managed by Palette. It's based on KubeVirt, but KubeVirt is only the enabling technology. We package it with all the additional components that are required to manage VMs at scale. It combines KubeVirt, obviously, but also Multus for networking, CDI, snapshot controller, the descheduler, pre-customized dashboard for observability, templates, example templates, and so on. In terms of features, and that will address one of the questions, VMO is available as an add-on pack in Palette, which means that it can be included in a profile. A profile is the desired state of a cluster. It means that if you create a profile to add VMO, you can add this profile with VMO to a fleet of clusters. For example, if you have 100 clusters, you can apply the same intended VMO state to that fleet of clusters. And that add-on will automatically deploy and configure Virtual Machine Orchestrator, allowing you to manage the same configuration in a consistent manner at scale. So on the left, in terms of management, we offer a friendly UI so that typical virtualization admins are not lost. but we also allow for API and Terraform management with our Terraform provider. On the right, you will have like regular virtualizations features such as HA, that VMs will automatically restart on a different node in case of a node failure. Auto balancing of the VMs based on the node consumption, which is equivalent to vSphere DRS. VM point-in-time snapshots, clone operations, templates for self-service catalogs, maintenance modes for physical node. So you always, I mean, even if it's 2024, we still have to conduct some maintenance operations on physical servers. So you need to be able to evacuate a node to be able to do that. Migration tool to import or onboard VMs from vSphere directly into VMO or OVA. What else? CPU hard, memory hard, networking hard, and so on and so on. Affinity and anti-affinity rules. So in terms of virtualization features, this is quite equivalent to what we have in vSphere Enterprise. So now it's time for the demo. I'm usually joking with that because it happened in the past that I had some issues with the demo. Let me just check in terms of timing, and I need to unshare and reshare. So this is Palette. This is our Kubernetes management platform that allows you to manage Kubernetes clusters at scale. So in that specific environment, I only have one cluster that is a canonical mass cluster. It's deployed with 6 nodes. So I have one control plane and 5 worker nodes that are deployed on physical servers. So those servers are in one failure domain. They have names here, and they've been up for almost a month. So because I have added VMO on that cluster, but let me show you actually how to add VMO. So to add VMO in the cluster profile, so I can just define a name. I'm saying that it's just an add-on to existing Kubernetes cluster. And I can just search out of the box. We support a lot of integration. As I said, we support certified 50 plus integrations that we maintain and lifecycle by ourselves. So I can add what we call a new pack, but we also support Helm charts. And I will just add orchestrator. So this style is VMO, so virtual machine orchestrator, where I can select the pack version. I can select some quick definition if this is proxied or direct. If I want to, and if I want to dig into the real configuration of the pack itself, I have access to the values in YAML here. That's not the purpose of the webinar today. And then I can just confirm and create. So I have one layer that can be added. So let me just finish this one. So for the sake of the demo and the time of the demo, I already added this to that specific cluster. So when that layer, virtual machine orchestrator, is added, I have a new virtual machines tab that is here. So I can select my namespace where I want to create my VMs. So I have a few enabled namespaces that are appended or prefixed with NS- advanced edge pack or product. And here in my namespace, I have 5 VMs that are currently running, but I can create a new one. For example, out of the box, we have a few templates that are available just as an example, but you can create all the templates that you want. So the cluster admin is completely free to offer the templates that are required for the business in that self-service catalog. So I can create Ubuntu 2022. I can create webinar VM. 2 CPU core. I will do 4 gig of memory and 80 gig of storage. And I can start the VM automatically after creation. So because the underlying enabling technology is KubeVirt, we also have access to that screen. So it's a more advanced screen. So this is the virtual machine kind that provides the intended state for the virtual machine itself. I can change also here the MAC address or some reservations. If I want to, I can do some cloud init here, and I can create the virtual machines. So this takes approximately 20 seconds. So it already cloned the disk, the Ubuntu disk, and the VM is starting, but I can just go to another VM as an example. So I can jump to that existing VM where I have access to a series of tabs, such as the overview, to details where I have access to like the affinity rule, the flavor of the VM, if some GPU or host devices are configured. I also have access to the console of the VM, just like in vSphere. So here I have like a Space Invader game that is running. And if I want to, I can trigger a live migration on that VM. So I can do migrate node to node. And I'm migrating this Shippy VM to another node. So I migrate node to node. So this VM is currently running on AZ132, and the state is currently migrating. So live migration is actually moving the VM live, so with no impact to the user or to the applications that are running in that VM. So when the VM will be migrated, it will run on the different node. So this usually takes a few seconds, depending. Here it's a lab environment, so it's not equivalent in terms of performances to production. But we can see that it's finished here, it's running. It moved into a different node, which is 133 now. And that doesn't have any impact for the VM, which is still running Space Invaders. So we support also all other day 2 activities. So you can add a new network interface. Here I haven't configured any network attachment definition, but I can add a new bridge or a new masquerade interface directly to the VM. I can do the same with disk, where I can just add a new disk, whether it's a disk CD-ROM. And in case of interface, I can use SCSI or SATA, but also VirtIO, which is the equivalent of PV-SCSI for vSphere. It's optimized for best performance. In terms of advanced capabilities, I can also take snapshots. So snapshots are useful if you want, before an upgrade of an application in a VM, for example, if you want to do some troubleshooting of a VM, sometimes for forensics. You know that a VM has been compromised, so you isolate the VM and you want to take a snapshot of how it's running right now. So you can run a snapshot. It just says that the cloud init disk 0, which is my CD-ROM that installed Ubuntu, or in that case Fedora, will not be snapshot. I can save and the snapshot will be created. Just similarly, I can clone the VM and so on. I can configure affinity and anti-affinity rule and so on. I mentioned earlier node maintenance. So for example, here I have my node pool. So I can check the node details where I have some information in terms of CPU, memory, the state, the condition of the node. But I can also turn on maintenance mode, which will evacuate all VMs and all pods running in that node seamlessly, so with no impact for the workloads. So I can continue. So the node will be drained and then cordoned so that no other pods and VMs can be scheduled on it. And this has no impact on your applications. So I can see that the maintenance mode is initiated and that it will be done. It will be finished later. At the cluster level, I can see that one node is in maintenance at the top. I could go and continue the demo for long, but I'm also conscious of the time, of everyone's time. I will just check the question. So I have a question about storage. How is storage handled? How does VMO present persistent storage to containers and VMs and protect data? So in terms of storage, you have all the capabilities that Kubernetes have, including PV and PVC, so persistent volumes and persistent volumes claims. And you have all access. So in that specific case, because we don't, in that lab, we don't have any external storage to attach to those nodes, we're using Rookceph, which is an HCI-based component. But you can also do, use Portworx, Longhorn. We support any type of NFS, IceQZ, fiber channel storage that you will attach to the cluster, and the VMs can create then data volumes or persistent volumes for that. I understand I had the same struggle like more than a year ago before I started with VMO, because I've been doing Kubernetes for a while now. And I've been always also told that containers are ephemeral. But with KubeVirt, there's a few things that changes and that makes the VMs persistent, and that have the VMs have their desired state. So if I go to virtual machines, for example, if I pick one of my VM, they have the intended running state. So they are either powered on, powered off, and so on. So it's you that defines if the VM is running or not. So the VM that is running here, it has in the YAML somewhere, because you have clicked on power on the VM, it has the intent of the VM, which is running. If I can find it, condition true. So the status is running, and we have some data volumes attached to it. Okay, I will continue with slides, and then I will end with other questions at the end. Let me just share and unshare. All right. So VMO, so virtual machine orchestrator. So we have seen that it's one feature that's able to run VMs in Kubernetes. But if we zoom out, it's actually one feature that is part of Palette that has a lot of additional features. And I don't have the time to cover everything, but in the 60-second speech, I will just mention that Palette is a Kubernetes management platform with a distributed architecture that enables the management of one or hundreds or thousands of endpoints and Kubernetes clusters. So one unique part of our IP is the ability, what we call day zero, to model what your Kubernetes clusters should look like from the bottom to the stack up to the top of the stack. So at the bottom, you have the operating system, the Kubernetes layer, the storage, the CNI, the CSI, and then all other integrations that you want that are required for your applications to run correctly. So this is done in a reusable blueprint that we call cluster profile. So it describes those cluster profiles, describes the entire stack of what your Kubernetes should look like. Also, we can manage the complete life cycle. So I just mentioned day zero, where you model what your cluster should look like. Day one, to deploy and clusters on a large set of cloud ecosystem, whether it's on-prem, on bare metal, on vSphere, OpenStack, public cloud, managed Kubernetes, at the edge, far edge locations, and so on. And we also offer day two operations. So regarding certificate, airbag, visibility, auto healing, dashboards, costs, quotas, and so on. So you can manage the complete life cycle of your Kubernetes clusters wherever they are running. So we have all those benefits for containers that are also available for virtual machines. We have flexibility, we have choice. We build on cluster API and open source component. We make bare metal easy. We have a rich ecosystem out of the box with a lot of out of the box integrations, what we call add-ons. So there are a few here that are mentioned. Also, we do have a public sector or federal version of Palette that is named Palette Vertex, which is FIPS compliant. So the management plane is completely FIPS compliant and certified for it, and which also allows to deploy target cluster in FIPS compliant. We also support hybrid application at the edge, where we also support VMO. To conclude, I will just re-emphasize some things. So VMs are here to stay. Again, VMs are here to stay, wherever we like it or not. We need to find a way to manage both VMs and containers in a sustainable manner at scale. So one option is to completely have two different IT teams, two different IT estates and so on, but this is not sustainable at long term. Do-it-yourself KubeVirt is an option, but it's really hard to deploy, to maintain, to certify the integration between all the moving parts and so on. And other management Kubernetes platforms or tools that have a KubeVirt integration are very opinionated and introduce the same vendor locking that you had with proprietary solution, often at a very expensive cost or with weeks or months of professional services. And that's why really Palette Virtual Machine Orchestrator offers a perfect solution to manage both VMs and containers in the same platform at scale. And you don't need to commit to a massive lift and shift migration. You can move workloads over time, like we have customers that do that. And as you and your stakeholders gain confidence, you can make every Broadcom contract a little bit smaller over time. And just before answering the last questions, in terms of next steps, if you want, there are a few short links here, or you can scan the QR code. But if you want to show just a quick run of a 5 minutes demo from Saad Malik, our CTO, about VMO, or book a one-to-one demo of Palette to get started, or just have a look at our doc site, which explains everything in detail. And also don't forget, there's another webinar in 2 weeks. That's right, it's in 2 weeks on the same topic. So Jeremy and Jared will be sharing another approach on the same challenge with real world examples of how enterprises and how they are adjusting to the change. So now let me go back to the questions that I've seen. Okay, I've seen a few actually. Let me start by the bottom. I have answered about questions about features, advanced features that vSphere offered, like HADRS, affinity rules, and so on. So VMO supports all of that. KubeVirt also supports some of that out of the box or requires additional component. We packaged everything in our solution. We are taught that containers are ephemeral, immutable. How does a VM in container support the change updates or the attempts on a case where we don't allow for alters? Where VMO introduce some encapsulation of the pod, and then a VMI, which is a VMware VM interface, and then a VM component, and really takes care about that. So outside of regular cloud native principles, saying immutable or ephemeral, this is taken care by KubeVirt, and it just runs like any other virtualizations aspects. What happens when you have VMs and containers on the same node, and when you do a node maintenance? That's also one question. Well, the node maintenance is being a drain first and then a cordon. The VMs itself, and that goes back to the previous question, are considered as long-running objects and not ephemeral ones. So they will be live migrated to other nodes. The pod themselves are considered as ephemeral, so the ones that are not managing VMs are considered ephemeral. They will be killed and restarted on other nodes because we consider that regular containers and pods are ephemeral workloads. So those will be restarted and killed and restarted. So here there's also some, just like in a regular Kubernetes environment, there are also some effort required by the app team to correctly design the applications on the pure Kubernetes side. One additional question: does the underlying storage have to support CSI, or can it be vanilla NFS? No, it can. Actually, let me think. It can. Does it need to support CSI? There is a CSI for NFS, or you can just support regular NFS out of the box. Yes. And let me check. I think I answered all the questions. So one more slide. Don't hesitate to join our community Slack channel on spectrocloud.com/community, where we can discuss. You can ask questions, or you can also check our Kairos, which is an open source project for immutable OS at the edge that we support. And that's it. Don't hesitate to reach out to us if you have any additional question, or to actually scan one of those QR code before I'm leaving. Thank you for joining. Thank you for the question. It has been my pleasure, and I hope we will be in touch soon. Bye.